The article does not state that you can supply an AC unit and furnace on the same branch circuit, even if the nameplate ratings are comparable. The article indicates that if the nameplate ratings of the AC unit and furnace are not comparable, then you can supply them with separate branch circuits. This implies that you should not supply an AC unit and furnace on the same branch circuit if the nameplate ratings are different. The primary reason for this recommendation is that the AC unit and furnace typically draw different amounts of current. If they are connected to the same branch circuit, the circuit could potentially overload, leading to the tripping of the circuit breaker. Furthermore, the AC unit and the furnace might not operate efficiently or as intended if they share the same branch circuit. Therefore, to ensure safe and reliable operation, it is generally advisable to supply an AC unit and a furnace with separate, dedicated branch circuits. When dealing with electrical installations involving heating, ventilation, and air conditioning, or HVAC systems, it's essential to adhere to established electrical codes and best practices. The National Electrical Code, or NEC, provides comprehensive guidelines for the safe and proper installation of electrical equipment, including HVAC systems. Branch circuits are a fundamental concept in electrical wiring. A branch circuit is defined as the circuit conductors between the final overcurrent device protecting the circuit and the outlet or outlets. In simpler terms, it's the wiring that runs from the circuit breaker in your electrical panel to the devices or appliances that it powers. Overcurrent protection is provided by devices like circuit breakers or fuses. These devices are designed to interrupt the flow of electricity if the current exceeds a safe level, preventing overheating and potential fires. Each branch circuit is designed to handle a specific amount of current, typically determined by the size of the conductors, the rating of the overcurrent device, and the type of loads connected to it. Connecting multiple high-current appliances to the same branch circuit can easily overload it, leading to nuisance tripping of the breaker or, in more severe cases, overheating and fire hazards. Nameplate ratings are crucial pieces of information found on electrical equipment. The nameplate provides essential details about the equipment's electrical characteristics, including its voltage requirements, current draw, power consumption, and other relevant specifications. These ratings are used to determine the appropriate size of the branch circuit needed to supply the equipment safely and reliably. When selecting a circuit breaker for a branch circuit, it's important to choose one that is appropriately sized for the intended load. The circuit breaker's amperage rating should be high enough to handle the normal operating current of the appliances or equipment connected to the circuit, but not so high that it allows excessive current to flow in the event of a fault. Overloading a circuit can have serious consequences. Firstly, it can cause the circuit breaker to trip repeatedly, interrupting the power supply and causing inconvenience. Secondly, it can lead to overheating of the wiring, which can damage the insulation and create a fire hazard. Thirdly, it can damage the appliances or equipment connected to the circuit. For these reasons, it's crucial to avoid overloading branch circuits. When installing an AC unit and a furnace, it's important to consider their individual electrical requirements. AC units typically have a high starting current, which is the amount of current they draw when they initially start up. This starting current can be several times higher than their normal operating current. Furnaces, on the other hand, typically have a more consistent current draw, but they may also have auxiliary components like blowers and electronic controls that require additional power. Given these differences in electrical characteristics, it's generally not advisable to connect both an AC unit and a furnace to the same branch circuit, even if their nameplate ratings appear to be comparable. The high starting current of the AC unit could potentially overload the circuit, especially if the furnace is already running. Moreover, the combined current draw of both appliances could exceed the circuit's capacity, leading to tripping and potential hazards. In most cases, it's recommended to provide separate branch circuits for the AC unit and the furnace, each with its own appropriately sized circuit breaker. This ensures that each appliance has its own dedicated power supply and that the circuit is not overloaded. When selecting the appropriate size for the branch circuit conductors, it's important to consult the National Electrical Code, or NEC. The NEC provides tables that specify the minimum conductor size required for various ampacities. Ampacity refers to the current carrying capacity of a conductor. The NEC also provides guidelines for dirtying conductors when they're installed in certain conditions, such as in conduit or in hot environments. Dirtying reduces the allowable ampacity of the conductor to account for the increased heat generated under these conditions. When determining the appropriate size of the circuit breaker, it's important to consider the ampacity of the conductors and the nameplate ratings of the appliances or equipment connected to the circuit. The circuit breaker should be sized to protect the conductors from overcurrent, but it should not be so small that it trips unnecessarily. The NEC provides guidelines for sizing circuit breakers based on the type of load connected to the circuit. For example, the NEC specifies different sizing requirements for motor circuits compared to lighting circuits. In addition to providing separate branch circuits for the AC unit and the furnace, it's also important to ensure that the wiring is properly installed and grounded. Grounding provides a safe path for fault current to flow back to the source, which helps to protect against electric shock. The NEC provides detailed requirements for grounding electrical systems. It's also important to ensure that all electrical connections are properly made and that the wiring is protected from physical damage. Damaged wiring can create a fire hazard or increase the risk of electric shock. When working with electrical wiring, it's always important to take precautions to ensure your safety. Firstly, always turn off the power to the circuit before working on it. You can do this by switching off the circuit breaker that controls the circuit. Secondly, use insulated tools to avoid electric shock. Thirdly, wear safety glasses to protect your eyes from debris. Fourthly, never work on electrical wiring when you are wet or standing in water. Electricity and water are a dangerous combination. Fifthly, if you are not comfortable working with electrical wiring, it's best to hire a qualified electrician to do the work for you. Electrical work can be dangerous, and it's important to take the necessary precautions to ensure your safety. Firstly, electrical codes and regulations are in place to protect people and property from electrical hazards. These codes and regulations are constantly evolving to reflect new technologies and best practices. Secondly, it's important to stay up to date on the latest electrical codes and regulations to ensure that your electrical installations are safe and compliant. Thirdly, the National Electrical Code, or NEC, is the most widely adopted electrical code in the United States. The NEC is updated every 3 years to reflect changes in technology and best practices. Fourthly, local jurisdictions may also have their own electrical codes and regulations that are more stringent than the NEC. It's important to check with your local authorities to determine the specific requirements for your area. Fifthly, when planning an electrical installation, it's important to consider the long-term needs of the building or facility. The electrical system should be designed to accommodate future growth and expansion. Sixthly, it's also important to consider energy efficiency when designing electrical systems. Energy-efficient lighting, appliances, and equipment can help to reduce energy consumption and save money on utility bills. Seventhly, regular maintenance is essential to ensure the safe and reliable operation of electrical systems. Electrical equipment should be inspected regularly for signs of wear and tear. Any damaged or worn equipment should be repaired or replaced promptly. Eighthly, electrical systems should also be tested periodically to ensure that they are functioning properly. Testing can help to identify potential problems before they become serious. Ninthly, hiring a qualified electrician is the best way to ensure that your electrical work is done safely and correctly. A qualified electrician has the training, experience, and knowledge to perform electrical work in accordance with electrical codes and regulations. Tenthly, electricians are also equipped with the necessary tools and equipment to perform electrical work safely and efficiently. In general, it is advisable to consult with a qualified electrician or HVAC technician to determine the specific electrical requirements for your AC unit and furnace installation. They can assess your existing electrical system, calculate the appropriate circuit sizes, and ensure that the installation meets all applicable codes and regulations. This will help to ensure the safe and reliable operation of your HVAC system.